This is Mr. Khumalo CS. In this video, I'm going to do the introduction to work energy and power. My videos will be addressing the bullets from the ATP. This is the ATP. So my today's video is going to address the bullet number 1 and bullet number 2. So bullet number 1 from the ATP says define the work done on an object, and bullet number 2 says draw force diagram and free body diagrams. So today's video is going to address the free body diagram issue. We all know that the free body diagrams have got a lot of marks from the physics paper 1. So it's very important to know how to draw a free body diagram. Now, bullet number 1 says define work done. Work done can be defined as the product of the force and displacement. That is work done. Mathematically, work done can be written in the form of W is equals to force times displacement times cos theta. Work done is measured in joules, force in newtons, displacement in meters. Now, with this formula, the only problem is this angle theta there. We say this angle theta there is an angle between the force and displacement. In the sense that when the force and the displacement, they are in the same direction, we will say this angle is equals to 0 degrees. For instance, if we say the force is going this side, let's assume that this is our force applied, and again let's assume again that the direction of the object is also in that side. So we'll say the angle between this and the force applied is 0 degrees because they are pointing in the same direction. But if we've got a situation whereby the force, the displacement of the object is going this side and the force acting on the object is going this side, in this case where we say this is the displacement of the object, and then acting to this other direction is the force applied. It can be the frictional force that always opposes the motion of the object. Then we know that this angle there is going to be 180 degrees. This 180 degrees is the angle between this force and that force. So this theta then, this angle there, is either always going to be 0 degrees or 180 degrees. It depends with the nature of the force, whether it's acting on the same direction or is acting on the opposite direction. Okay, now let's look at the bullet number 2. Precisely in bullet number 2, we'll be talking about the free body diagrams. So of course, we're going to do our free body diagrams for objects in the horizontal plane. First, let's look at the object in the horizontal plane and see how we can draw our free body diagram for this object. Okay. Now, these are objects in the horizontal plane. Let's start with object number 1, scenario number 1. Okay. Right. Let's draw the free body diagram for this object. Okay. Free body diagram. Right, when you draw the free body diagram, we'll represent the object as a dot or a point. Then we draw the forces acting in the object from the point, and they should be pointing away from that object. Right, the first force that we draw in our free body diagram, I always like to start with the weight of the object. Now, the weight of the object is always pointing or acting downwards from that object. straight downwards is the weight, and I can tell you there, since it's a flat surface or horizontal surface, we're going to have our normal force pointing up, straight upward like that. And these forces should be balanced because the object is not going up or down. Then along the motion of the object, we are going to have the force applied in that same direction. Where is it acting? Can you see? I'm taking it as it is from there. Then I check it there, and then I put it from there, my free body diagram, and the force must point away. And opposing that, I'm going to have the frictional force opposing the motion of the object. Very, very important to know that. So remember, I said this is my weight of the object, which is Fg. This is my normal force. This is my force applied. This is my force applied. And then this is my frictional force. Okay, so for mark allocation, this is going to be 1, 2, 3, 4. This is usually going to be 4 marks. Right, now let's look at the scenario number 2. Again, free body diagram for scenario number 2, we're going to represent this object as a dot or a point, and our forces are going to point away from this dot. Right. The first force that we're going to draw is the weight acting straight downwards. And again, we're going to draw our normal force acting straight upward. Now we look at this force. Look at this force is acting in that type of direction. So I'm going to take the force as it appears from the force diagram as it is. Then I take it, then I put it there in my free body diagram, and I know the force was pointing away from the object. Then I know that along the motion, I have my frictional force opposing the motion of the object. Right. Then I can say this is my Fg. This is my normal force. This is my force applied. And this is my frictional force, Fk. Minimax again is going to be 1, 2, 3, 4. It's going to be 4 marks. Now let's look at this scenario. Last one there. To draw the free body diagram of this object, we are going to represent this object as a point or a dot. Then we start drawing our forces acting in the object. We always start with the weight. The weight is always acting straight downwards. Normal force is acting straight upwards in the flat surface. And now we've got the force. Since the force is acting in this type of direction, we are going to take our force as it appears there, but we'll put it exactly as it like that from the force diagram. But remember, the force must be pointing away from the point or from our dot. So this force is going to be like this. In order for this force to point away from the dot, it's going to be like that. And we draw. draw our frictional force, which is the force that is opposing the motion of the object in this direction. So this is our FG. This is our normal force. This is our force applied. And then this is our frictional force. And again, we're going to have 1, 2, 3, 4 marks. Very, very important to know how to draw our free body diagram. So this was the free body diagram for the horizontal plane. Let's move to the inclined plane. Now this one is the inclined plane. Let's start with the first scenario there. Drawing the free body diagram will represent our object as a point. And again, we start with our weight acting straight downwards. Sorry for shifting there. Right, we start with our weight acting straight downwards. Object is always pointing away from the dot. Right, so in order for us now to draw the normal force, the normal force is no longer acting straight upwards, because remember, the normal force is the force, it's a perpendicular force exerted by the surface to the object. So now we need to look at this surface and also try to see how we can get that perpendicular force acting to the object. If you look at my ruler there, my ruler, you can see that is in the form of being perpendicular to this. So now we can see that this can be perpendicular to the surface. So the normal force is going to act in that type of direction. Okay. So my normal force would be in that type of direction. Right. And then now I need to indicate my force applied. The force applied is acting in that type of direction. So I'm going to put my force applied, and it's acting along the surface or the motion or the plane. Then opposing that, I'm going to have my frictional force. So these are forces now acting in that object. This is my FG. This is my normal force. This is my force applied. This is my FK, frictional force. Now, how many marks is there? And again, I'm going to have 1, 2, 3, 4. I'm going to have 4 marks there. Right. Now, let's look at the situation number 2. Again, we're going to represent our object as a point there. We start with our weight acting straight downwards. Weight acting straight downwards there. Forces are always pointing away from the dot. And the normal force, I can't draw the normal force straight up like that because my surface has to be perpendicular to the object. If you look at the object there, you can see that now if you look at my object there, you can see that now I've got normal force in this type of direction. Can you see that? In the sense that now my normal force will be perpendicular to that object. Can you see that? So my normal force, I'm going to put it like that here, as it is. That is going to be my normal force, as it is the forces acting perpendicular to the object, right? Then now I need to put my force applied. Force applied, you can see, is acting in that type of direction. So I'm going to take it as it is, and you know the forces are always moving away from the object, or the point, or from the dot. Then I've got my frictional force. Frictional force is always parallel to the surface of the object. So it's always force that is parallel to the surface of the object, as you can see. So it must be an act along this direction. So that will be my frictional force. So I'm going to take my frictional force that is acting downwards. Not downwards, it's opposing the motion of the object. Given that the object is going up, the frictional force is going to go down. And again, I can say that this is my Fg. This is my normal force. This is my force applied. This is my frictional force. And then this is going to be 1, 2, 3, 4. Right. Let's look at the last situation now. The last situation, we've got the box that is sliding down the plane. So of course we're going to start with our weight. The weight is always acting straight down. Okay, but then now the normal force, if you remember what we said about the normal force, it has to be the force that is perpendicular to the surface. So if I can indicate my normal force there, you will see that I'm going to have something like this. Should be my normal force that is perpendicular to the surface. Now I have to take my normal force as it appears there and draw it in my free body diagram. So I'm going to take it like that, and then I put it there. As you can see that I'm taking it as it is, just drawing it there, perpendicular to the surface. So my normal force is going in this direction. Then now I need to look at my force applied. I don't have a force applied because the object is sliding down. It's sliding down due to the weight. But as I have a frictional force, the frictional force is always parallel to the plane. Right. Parallel to the plane is always my frictional force. So in this case, my frictional force would be here, acting like this. So I have to take that frictional force as it is there and put it in my free body diagram. Because frictional force is always a force opposing the motion of the object. This object is sliding down, frictional force will act upwards like that. So in this case, that's going to be my Fg normal force, my Fk, the frictional force. So for marks, this is going to be 1, 2, 3. This will definitely be 3 marks. I hope you understand my videos. This is the free draw, just drawing the free body diagrams on an inclined plane, and We did also draw the free body diagrams in a horizontal plane. Very, very important to know how to do this. Very, very important. You're always going to get a lot of marks if you can know how to draw the free body diagrams in an inclined plane and also in a horizontal plane. Because when you've got the free body diagram, we can easily see the forces that are acting on the object. Now, if we know the forces that are acting on the object, we can then move to the next step, which is to calculate whatever that we're calculating. For instance, in this topic is work, energy, and power. We will be looking at the forces that are along the motion of the object, and those forces will be doing work. So, but this video was all about drawing the free body diagram. I'm going to do another video where I address the issue of calculating the work done. Please check my next video. It's going to be on bullet number 3 and bullet number 4. Thank you.